So today we're talking about linear programming word problems, and the last problem on this page is referencing a filing cabinet problem. You are being put in charge of buying filing cabinets for your office to hold a bunch of files, apparently. And you do some extensive research online and you find that there are two good filing cabinets that you need to choose, but you need to figure out how many of each you should buy. So we have cabinet X and we have cabinet Y. Now cabinet X costs only $10, and it only takes up 6 square feet of floor space, but it only holds this 8 cubic feet. So that's not a whole lot of files. And you find cabinet Y, which is twice as expensive, $20, and takes up a little bit more floor space, but holds 12 cubic feet of files. And so we need to figure out what cabinets we can buy. Now our manager says that we can only spend $140 in order to purchase these cabinets, and we know that there are only 72 square feet in the office itself for us to put these cabinets. So in order to do this, we need to take all this information and we need to write some equations to represent the limiting factors that are going to affect our purchase decision. So the first thing we should probably do is talk about the cost. We know that we can only spend $140, which means that I'm going to have a certain number of cabinet X at $10 a piece and a certain number of cabinet Y at $20 a piece. And this number will have to be less than or equal to $140. We do not have to spend all of the $140, so it can be less. Then we will also have the square footage limitation. This office is only so big. So however many cabinet X's we have and how many cabinet Y's we have, it's going to have to be less than 72 square feet. Now, we know that there are going to be a total of 6 square feet for each cabinet X and a total of 8 square feet of floor space taken up for each cabinet Y. And these would be my two equations that represent the limiting factors of this situation. We are going to take these equations and we are going to put them on the graph. So in order to do that, we'll probably want to convert this into slope-intercept form. And the first equation, we'll go ahead and subtract 10x from both sides, and we'll eventually divide by 20. And so that'll get me 20y is equal to negative 10x and then plus 140. Now that is not an equals, it is a less than or equal to sign. After doing the division by 20, we will find that y is less than or equal to a negative 1/2 x and then a positive 7. So this is my first inequality for this situation in slope-intercept form. We will start at a positive 7, and we will go down 1 and over 2. And we want to make sure that we do this nice and accurate because we're going to be graphing two lines on this graph, and we want to make sure that we have them nice and straight so we can see the intersection points. Here is my first graph. Now that first graph is going to also have a shaded region because this is an inequality, means I will have to buy this area right here. We cannot buy anything above this, a less than sign shades below. We cannot buy anything above that particular set of points, but we can be anywhere on the inside of the blue region. Now we'll go ahead and solve the other equation. We'll subtract 6x from both sides, and that'll get me 8y is less than or equal to a negative 6x plus 72. Dividing everything by 8 will get me y is less than or equal to, and negative 6/8 would reduce to negative 3/4 x, and 72 divided by 8 is positive 9. Now this is my second limiting equation, and what we want to do is we want to graph that on the same grid that we have over here. So we say negative 3/4 x plus 9, we will start at a positive 9 and go down 1, 2, 3 and over 1, 2, 3, 4. Down 3 again and over another 4, down another 3 and over another 4, and we will have this red equation right here. Alright, so this is the second limiting factor. Again, we want to make that as straight as possible so that we can see these overlapping regions. Now as far as the area of shading below there is going to be this yellow area. And you can see the area where the yellow and the blue overlap turns into this green color. Now this green area is where I could actually make my purchase. So if I wanted to, well, I could buy 2 of each. Now we know that 2 of each will work because it's in the shaded area, but it is not necessarily going to maximize the volume. We won't spend very much money and we'll get a little storage, but we're not going to get a lot of storage. And the question really says is, how many should we buy of each in order to maximize the storage volume? So what we've neglected to do is, well, come up with a storage volume equation, something that will maximize that. We know that the volume of what we purchase is going to be equal to 8 cubic feet times the number of the cabinet X's that we're going to buy, and 12 square feet or cubic feet of the number of cabinet Y's that we will buy. So this is my volume equation. We're going to try to maximize this volume equation. Now the maximums and the minimums are going to be found at the intersection points, the corners of these shaded regions. Obviously, we cannot buy less than 0 something, so we do have a boundary line on the X and Y axis as well. These are going to give me 4 points to check. The points that we have here are going to be 0, 7. This point right here is at 8, 3. And this point down here is going to be at 12, 0. Now, it is unlikely that 0, 0 is going to maximize this because then we would have no volume. So we're going to check these other bordering points and see which one gives me the largest number. So 0, 7. V is equal to 8 times 0 plus 12 times 7. So that would be 70 and 14 is 84. So volume is 84 for the first point. The second point, V, will be equal to 8 times 8 plus 12 times 3, plus 12 times 3. 8 times 8 is 64. 64 plus 36 is, well, 100. So far that is bigger. And then we'll test the last point just to make sure that that is not by some chance bigger than what the previous ones were. So that is 12 times 8, 8 times 12, plus, well, now we're buying 0 of the other cabinets, cabinet Y, so 12 times 0. And 8 times 12 is 96. So yes, we could buy 12 of cabinet Y and none of the other ones, but then we'd only get 96 cubic feet. The biggest of these volume numbers is going to be the 100. So the situation calls for us to buy 8 of the cabinet X and 3 of the cabinet Y's. So my solution would be 8, 3. 8 cabinet X's and 3 cabinet Y's. That'll maximize my volume and still stay under my $140 limit.